All right, we're going to look at linear systems really quickly because linear systems pop up in other classes. They appear in chemistry and they appear in physics, and they actually kind of are useful in life. There's lots of real world problems that we solve with systems. And also in grade 11, both in applied and in pre-cal, we encounter systems. And although we'll have to, probably do a bunch of just at least exposure to systems. So what is a system? A system is, for us, it's going to be two equations. A linear system can have more than two equations. It can have many. It can have tons. It can have thousands. But we're going to limit it to two. We're going to use two linear equations whose variables represent the same quantities. So they might have, each of those equations might have x's and y's in them, and those x's represent the same kind of amount of something, the same quantity of something. They represent the same kind of real world thing, and the y's would represent the same real world. Just have different different numbers kind of attached to them, and maybe different scenarios. They represent slightly different scenarios. Okay, so I know that's very confusing, but I promise it'll make a little bit more sense when we get into an example. So what's the answer to a linear system? Well, the answer is the values of the variables that satisfy both equations. Okay, so if we have x's and y's, what's the value of x and the value of y that works for both equations? So if I was to solve for x and I was to solve for y, which of the possibilities, of all the possibilities of x's and y's, would actually satisfy both equations? Okay, so graphing is probably the easiest way to wrap your head around what a system is. It's going to, if we're having two linear equations, that means we're going to have two lines. And when we want to find out the answer to a system, when we graph it, it's going to be where the functions intersect. Okay, and so these are often ordered pairs. Okay, so where the functions intersect is the answer. Because that will be the value of x and the value of y that's on both of those lines. So it satisfies both of those equations. Okay, and hopefully this example works. Will help kind of make sense of that. So we want to solve this system. So we've got two linear equations, and both of these guys are in y equals mx plus b form. So graphing is a great strategy when you're given y equals mx plus b form. Okay, if you're not, okay, you might want to change it. To y equals mx plus b. And we did a bunch of practice with that both of the times that we did graphing units. Okay, so let's start with the first function, y equals 4x plus 3. Remember, please, that is your y-intercept, and this is your slope. So hopefully we can graph y equals mx plus b by now. If not, go back, look at your notes again. Make sure you're comfortable with what we're doing here. Our y-intercept is 3, and from there our slope is 4 over 1. Okay, so normally I would go up 4 and over 1, except I would run out of room here. So I'm going to go down 4, 1, 2, 3, 4, and back 1. And then you can see how my slope is still going to be positive. I'm going to go down 4, 1, 2, 3, 4, and over 1 here. And this is why I wanted you guys to use at least 3 points to make your lines. And I want you to use straight edge, because what we want to do is we want to find out where this line intersects. I'm going to get a different colored pen, get green here for this line. And we're starting at -2. And then our slope is -1 over 1, right? So we can put a 1 over 1 there. So we're going to go down 1 over 1. We got to make sure our slope is negative. And we can have lots of points for this guy. It's pretty easy. And we want to draw really good lines that match up with our points, because we want to find the point where they intersect. If we don't use a ruler or we don't have enough points to kind of really draw an accurate line, our answer might be off. All right, so we're almost there. We've graphed 2 lines quite successfully, but we haven't answered the question. So what is the solution to this system? What are the values of x and y that satisfy both equations? So we've got a whole bunch of values. We can see all these ordered pairs on this green line here, right? They all satisfy this line. And then our purple line, we can see there's, you know, an infinite number of points along this line that satisfy that line. But there's only one point in this case, and usually there's only one point that satisfies both lines, and that's that point of intersection. So our answer here is actually -1, -1. That's our final answer. And we don't forget to write the answer. That's the concept, right? Solving the system means finds the values of the variables. We have x's and y's. Here's my x, here's my y. We could also write x equals 1 and y equals 1. We could write that. Oh, sorry, negative. Those are negatives. We could write that as our answer too. Okay? A really good thing to do would be to check that these work. Substitute -1 and -1 here. So 4 times -1 is -4, plus 3 is -1. Hey, that's what y equals. So that works. And then -1 is 1 minus 2 is -1. Hey, that's what y is there too. So our answer is a good answer. Okay, so we should always check our work. All right. In all the independent practice you have, you should get nice whole number answers. Okay, so watch for that. But please note too that that's just not reality, right? We use systems kind of all the time in lots of different branches of math and lots of different kind of problem solving techniques in science classes and things. You don't often always get these really nice numbers, right, like this. So you might have to approximate answers, okay, or use graphing technology, or turn to an algebraic strategy, which is what we're going to look at in the next video.